In the previous lectures, we have discussed the Laplace transform. Now in this presentation, we are going to have the review of LTI systems. So let's get started. The linear time invariant systems play an important role in control systems, in signal processing, and in various other fields because the analysis and modeling of these systems is simple. So let's start with some important points of LTI systems. LTI systems are a combination of linear and time invariant systems. As the name suggests, these are a combination of linear and time invariant systems. And that's why these systems follow the properties of both linear systems and the time invariant systems. The linear systems follow the superposition principle, which is a combination of additivity and homogeneity. We have discussed additivity and homogeneity principles in the linearity property of Laplace transform. And the time invariant systems follow the time invariance property. And it says that if you time shift your input signal, your output would be exactly the same as you time shift the response to the original signal by the same amount. That is, any delay in input will result to the same delay in the output. And the LTI system is a combination of these two systems. So now we know that the LTI systems are a combination of linear systems and the time invariant systems. Let's understand this thing with the help of an example. And the example is given as x1t is a function which is having a rectangular waveform from 0 to 2, and it is given as an input to the LTI system, and its response is y1t. x2t is another function which is having this waveform, and it is given to the same LTI system, and it gives the response y2t. Now we need to write y2t in terms of y1t, where y2t is the response of LTI system when x2t is given as an input, and y1t is the response of same LTI system when x1t is given as an input. So they are asking the relationship between y2t and y1t. In that case, there must be a relationship between x2t and x1t. So now I want you all to pause this video and try to figure out the relationship between x2t and x1t. And then after that, we will move on to the solution. Now moving on to the solution, we are given x1t, which is having a rectangular waveform from 0 to 2. That is, the value of this function from minus infinity to 0 is equal to 0, the value from 0 to 2 is equal to 1, and the value from 2 to infinity is 0. Now if I time shift this function on the left hand side by a factor of 1, then we will get x1 of t plus 1, and its waveform will be a rectangular function from minus 1 to 1. If I time shift this function on the left hand side by a factor of 1, then 0 will shift to minus 1 and 2 will shift to 1. And that's why its value from minus infinity to minus 1 will be equal to 0. The value from minus 1 to 1 will be equal to 1, and the value from 1 to infinity will be equal to 0. So now we are going to add these two functions, and let's see what is the resultant waveform. So the value of x1t plus 1 from minus infinity to minus 1 is equal to 0, and the value of this function from minus infinity to minus 1 is equal to 0. So if we add these two functions from minus infinity to minus 1, we will get the resultant value equal to 0. And from minus 1 to 0, this function is equal to 1 and this function is equal to 0. So if we add these two functions, then 1 plus 0 will be equal to 1. So the resultant waveform in the left hand side will look like this. It will be equal to 0 from minus infinity to minus 1, and it will be equal to 1 from minus 1 to 0. Now moving on to the interval from 0 to 1, x1t plus 1 is having the value equal to 1, and x1t is also having the value equal to 1 because it is having the value equal to 1 from 0 to 2. So if we add these two functions from 0 to 1, 1 plus 1 will be equal to 2. So the resultant value from 0 to 1 will be equal to 2. Now moving on to the next interval from 1 to 2, x1 of t is having the value equal to 1 and x1t plus 1 is having the value equal to 0. So if we add these two functions, then the resultant value from 1 to 2 will be equal to 1. And now from 2 to infinity, the value of both the functions are equal to 0. That's why the resultant value will also be equal to 0. And now we have got our final waveform after adding these two functions. And if we observe this waveform, this is the waveform of x2 of t. So we can say that x2t is the sum of x1t and x1t plus 1. So x2t is equal to x1t plus x1t plus 1. So we can say that x2t waveform is the linear combination of x1t and x1t plus 1. Now, if we are having an LTI system and if I give x1t as the input to the LTI system, then the response is equal to y1t according to the example. Now, if I give x1t plus 1 as the input to the same LTI system, then by time invariance property, the response will be equal to y1t plus 1, which is the time shifted version of the response of x1t. Now, if I add these two functions, then we will have x1t plus x1t plus 1, and by linearity property its response will be the individual addition of these two responses, and it will be equal to y1t plus y1t plus 1. This is the property of an LTI system. It is following the properties of both the linear systems and the time invariant systems. Now x1t plus x1t plus 1 is equal to x2t. So we can say that y1t plus y1t plus 1 is equal to y2t. In this way, we have written y2t in terms of y1t. So now we are done with this example. We will now move on to the next point. The next point of our discussion is given as, in an LTI system, all the initial conditions are 0. Now this is one of the most important properties in LTI system. All the initial conditions must be equal to 0. I'll explain you what are the initial conditions, but firstly we will understand the reason that why the initial conditions must be equal to 0 in the case of LTI systems. So the total output in any system is equal to ZIR plus ZSR. ZIR is the zero input response, and ZSR is the zero state response. ZIR is the response of the system when the input is equal to 0. And ZSR is the response of the system when the input is given to the system. So whenever we will give the input to the system, we will have the ZSR, and if the input is equal to 0, then the zero input response will come into the picture. The zero input response is due to the initial conditions of the system. And if the initial conditions are not 0, then the total output will not be equal to 0. It will be equal to ZIR. Now in case of linear systems, if input is equal to 0, then output must be equal to 0. It is a property of linear systems that if input is equal to 0, then output must be equal to 0. That is, the initial conditions must be equal to 0, because if the initial conditions are not equal to 0, then the zero input response will come into the picture. Then the total output will not be equal to 0, it will be equal to ZIR. But in case of linear systems, the output must be equal to 0. That is, the total output in case of linear systems must be equal to ZSR. It means that whenever we will give the input to the linear systems, then only the output will come into the picture. Now suppose if the initial conditions are not 0, then in that case the zero input response will come into the picture, and if the input is equal to 0, then the output will not be equal to 0. And if the input equal to 0 and output is not equal to 0, then the system will not be a linear system. And if the system is not linear, it will not be LTI. So we can say that for the system to be an LTI system, the initial conditions must be 0, the zero input response must not exist in the total output, and the total output must be equal to ZSR, that is the zero state response. This is the must condition for an LTI system. Now you must be thinking that how we can get the output without applying the input, or what is the significance of this zero input response. So let's understand this with the help of this example. We all have torch lights in our homes, and these torch lights run on batteries. The capacitors present inside the battery have charges stored in them, which is the power source for this torch. And in this case, we are not applying any external input to this system. So the charges present inside the capacitor of the battery are kind of an initial condition of this particular system, and they are providing a zero input response because we are not providing any external input. The input is applied to the system when we need to charge this battery. So in this way, we can have the output without applying any input due to the initial conditions of the system. So now I hope you have got the significance of the zero input response, and in this way we are done with this lecture. Thank you for watching this lecture. I'll end this lecture here. See you in the next one.